Hi everyone. So today we are going to talk about design patterns. So I'll be basically following Headfirst Design Patterns book in this series. It is a very good book. They have explained it very nicely with examples, and anyone can understand it very in a real way. They have explained it like how these scenarios would occur in while you are writing code and how you can make use of the design patterns. Okay, so first of all, before diving into design patterns, let's try to understand what exactly is a design pattern. So design patterns are basically it defines, to certain problems, how can you write a better code which is scalable if in future if you want to add something, if you want to remove something without having less impact in different parts of your application. So that is why we make use of these design patterns, and it is very important as we grow, as we work in a day-to-day coding practices. It becomes inevitable. So the first thing that we are going to learn about is today's strategy design pattern. So before diving into what is strategy design pattern and what it states and um, how do we go about directly deep diving into the pattern, I'll first give you a problem statement, and then we will think through like how we can design that problem, and then we will see how strategy design pattern unfolds over there. Okay, so I'll let's take an example. Like there is a simulator duck gaming app which your company has developed. Okay, now it has a abstract class called as duck. Okay, abstract class called as duck. Or even before going to abstract classes, let's say it is a concrete classes itself. Okay, and it has following functionalities like swim is there, right? Ducks can swim, ducks can quack, right? And then what else ducks can do? Then they have their respective display behaviors, right? So there is this parent class called as duck, which has swim, quack, display. Okay. Now all ducks can swim, all ducks can quack, all ducks can display. I mean, display as in how they look like. Okay. Now, your company decided now for this, and there are a bunch of child classes which this duck class is being extended to. Okay, so there are real world duck classes like mallard duck. Okay, there's one type of duck called as mallard duck. Then there is redhead duck. Okay, which are extending, and they're using these parent classes methods, right? So in this way, we are making use of inheritance to have code reusability, right? So your company decided that now I want ducks to fly as well. So as a developer, what you will do? You have these set of classes. You have a duck class. So there's a fly feature that needs to be implemented. What you will do as a developer, the first thing that comes to our mind is very simple, right? Just add a fly method, right? So the ducks would fly. All ducks would now have this fly capability as well. Okay. But what happens that somewhere in your code, now there are thousands of such child classes are there, mallard duck, redhead duck, and in there is also one duck class called as rubber duck, which you weren't aware of. Now you added the functionality. Actual duck should fly, but rubber duck should not fly. That is how the behavior was supposed to be. You did not know, you just went ahead, added this fly method. You did not know that there was a rubber duck which is getting impacted. right? Now rubber ducks could also fly. So this was a big bug in your application. How could we resolve this bug? The simple thing that comes to our mind is, okay, I'll create one interface. So what I will do, I'll override it to do nothing. The first thing that comes to a mind, even before interface, okay, since rubber duck should not fly, and neither it should make quack, so I will override it to do quack. I will make it override to do to squeak, right? And fly, I'll do nothing. Very simple, right? I can override it to do nothing. But now what is the issue with this? Now it is okay as far as there are one or two, three classes, right? You can simply override the methods which isn't really required. But what happens if it is more than three, four, five classes? It becomes a maintenance problem. Here, the disadvantage of inheritance becomes pretty clear. You have to take care every time a new class is coming. You have to see all the features, all the functionalities. Lot of things you need to, as a developer, you need to think through before implementing a new class. So this is a maintenance overhead. What could be the better option for this? I know this fly and quack feature will not remain same. Its specification will differ. Right now I have a rubber duck. Tomorrow I will have a decoy duck. And next day I can have another set of ducks. So what the better thing would be, I'll use this fly and this quack into an interface. So now I have a flyable interface which has an abstract method called as fly. Okay. And then I have a quackable interface which has an abstract method called as quack. Okay. Now I will, apart from extending, and I will remove fly and quack from here. Only what is common shall remain here, which is common to even to the rubber ducks or any other ducks, right? So I'll keep only those functionalities in this duck class. Now I have created an abstract class. So all these ducks, apart from extending duck class, they will also implement these interfaces and write their own custom logic of fly and quack. Okay. So if rubber duck wants to squeak, so I will implement quack in that fashion that it will squeak. Now, if a fly is not required, I'll override it to do nothing, right? So this is one of the easiest things that we can think through. Now, what is the issue with this approach? Now, let's say in fly method, okay, I want to make amendments. So all the concrete classes, okay, which are actually implementing flying with wings, right? Let's say they have flying with wings and do nothing, right? And do nothing. This is what we have seen so far. So all these real birds are flying with wings and I want to make changes with flying with wings. Okay. So now I have to go ahead and keep on changing all these subclasses too, whatever the implementation. So code reusability is never being used, right? So this is one of the biggest drawback of this approach. So we see that maintenance is a bigger headache when it comes to implementing the inheritance. If there are changing functionalities and in terms of scalability, if we think through. So how can we avoid that? Okay. So this was the initial like problem statement. I wanted to give you an overview to understand how functionalities are, how things are changing, and how as a developer we are thinking through, and how we will right now proceed to strategy design pattern. Hope this was clear up to till this point. What are the issues with inheritance, and what is the biggest drawback in the approaches we thought through? Okay. So thank you all. We'll see you in the part 2 of this lecture.